All right, let's talk about the periodic table. For a lot of us, it's just this intimidating poster on a science classroom wall, right? But what if I told you it's actually a cheat sheet, and that by the end of this explainer, you'll know exactly how to use it to nail those exam questions? Let's dive in. Does this feel familiar? You spend time trying to memorize the table. You feel like you've got a handle on it, but then you get into the exam and poof, the marks just seem to disappear. It's so frustrating. And you know what? It almost always boils down to missing one single core idea. So, what if you could tackle pretty much any question an examiner throws at you about the periodic table with just one sentence? That's what we're here to do. We're going to find that one sentence that makes everything else just click into place. Okay, here it is. This is the sentence. The periodic table is arranged so that elements with the same number of outer shell electrons are in the same group and have similar chemical properties. You might want to screenshot this or just burn it into your brain. This isn't just another fact to memorize. It's the master key. Literally everything about why the table is shaped the way it is and why elements act the way they do flows from this one concept. It's your foundation for every single answer. So how do we actually use that sentence? Well, we start by looking at the table in a new way. Stop thinking of it as a list of elements. From now on, I want you to see it as a map, an electron map. Every single box isn't just a place for an element. It's a specific address that tells you a story about its electrons. So every map needs coordinates, right? Here are ours. The vertical columns, running up and down, are called groups. And here's the key thing. Everything in the same group has the exact same number of outer shell electrons. And because of that, as you see at the bottom, they have similar chemical properties. Now the horizontal rows, going from left to right, are the periods. They tell us something else entirely. How many electron shells or energy levels an atom has. So what's the logic that organizes this entire map? Here's a really common mistake people make. They think it's arranged by atomic mass. It's not. It's all about the atomic number. As you read the table like a book from left to right, the atomic number goes up by 1 every single time. And that means each element gets 1 more proton and, for us, 1 more electron that needs to find a home. Okay, so we get the layout. It's a map. But why is it organized this way? Why is this one of the most powerful tools in all of chemistry? Because an element's position on this map isn't just its address, it's its entire personality. Its location tells you exactly how it's going to behave, and it all comes down to those electrons. So let's be crystal clear about the real stars of the show here, the outer shell electrons. These are the electrons in last outermost energy level of an atom. You could think of them as being on the front line. They're the ones that actually interact with other atoms, and they are single-handedly responsible for deciding the chemical fate of their element. And here's exactly what that looks like. The number of outer shell electrons an element has tells you everything. Is it going to try and get rid of an electron, or maybe try to grab one from a neighbor? Or will it share electrons with another atom? That one decision, lose, gain, or share, determines how it reacts and the kinds of bonds it can form. That's the direct link between the map and real-world chemistry in a nutshell. Okay, theory is locked in. Now for the really important part, turning all this into exam points. This is your playbook. This is how you start speaking the exact language that gets you top marks from an examiner. This is it. This is the formula for a perfect answer, every single time. It's a simple, 3-step chain of logic. First, you mention the group number. Second, you state that this tells you the number of outer shell electrons. And third, you connect that number directly to its chemical behavior. If you follow that simple A leads to B leads to C logic, you are literally speaking the examiner's language. And let's get even more specific. Think of this as your vocab cheat sheet. On the left, you've got the phrases that win you marks: atomic number, group, outer shell electrons. You have to be precise. On the right, these are the traps that lose you marks. Don't talk about mass, and please, never just say something vague like, they behave the same. You have to explain why. And the why is always, always because they have the same number of outer shell electrons. Okay, we're on the home stretch. Before we finish up, let's just do a really quick final check to make sure these key ideas are completely locked in. This should give you the confidence you need to walk into any exam. All right, this is your final mental checklist. Before that exam, just ask yourself these 3 things. Number 1, what does the group number tell me? It tells me the number of outer shell electrons. 2, what does the period number tell me? The number of electron shells. And 3, how is the whole thing organized? By increasing atomic number. If you know those three things cold, you've got this. So I'll leave you with a final thought to completely change how you see this chart from now on. Is the periodic table just a boring list of elements? Or is it something way more powerful? A map of electrons that predicts exactly how they're going to act. Once you see it that way, it stops being something you have to memorize and becomes a tool you can actually use. Thanks for joining me.